think about our list on page 333, we have our basic antiderivatives, but there are some missing. I mean, so if you think about our derivative rules, we had rules for everything. I mean, we had power rule, we had e to the x, 2 to the x, ln x, other logs, we had sine, cosine, tangent, even the other trig functions, secant, all those. We had arc sine, arc cosine. We had derivative rules for everything. Antiderivative rules, not so much, right? We got the power rule, we got e to the x, we got 1 over x, the antiderivative is log. We had the arc sine, arc tangent going backwards. If it's 1 over 1 plus x squared, we know it's arctangent. So we had a few of those that are in reverse. But there were some missing ones that we didn't have. For example, but now we've talked about a few of them. For example, tangent x. Okay, what's the antiderivative of tangent x? It's like negative ln cosine plus c. Now, a few people I've talked to have said that, that's not a bad one to memorize if it shows up, because it could show up on the gateway test, right? If it shows up as part of a problem or just a problem by itself, if you've got it memorized, you could just put it down, right? Otherwise, how did we say you would work it? Sine over cosine. So we said you would make this sine x over cosine x. So on some of these, you kind of have a choice. There's a way to do them, or maybe you could memorize them, right? Maybe we could have added those to our list and said, hey, maybe you should just memorize this. But we would do a u substitution. We'd let u be cosine. The du would be negative sine x dx. And so everything is right there that you need except for that negative. So there's your sine dx. So that's a negative du. And the bottom is the u, so 1 over u. So we get negative ln u, and the u is cosine x. So maybe that's worth memorizing. I don't know. Or maybe not. Up to you. But you might have to do the antiderivative of tangent, right? So either be able to understand you got to write it sine over cosine, do a u substitution, or maybe just memorize it. Now, there was a problem in the book. I don't think we did it, but it said that's the same as ln secant x. Now, anybody right off the top of their head know why those two would be the same? Has to do with a log property. Remember this number out in front you can put inside as a power, right? So that negative 1 could go in there and it'd be 1 over cosine, which is secant. So either one of those actually would be acceptable answers. And then, of course, the other one that would go with that would be cotangent. Make it cosine over sine, let u be the bottom, let u be sine. The du would be cosine, there'd be no negative, and so it would just be ln of sine. So cotangent, the antiderivative is ln of sine. Okay, again, not a big deal, not worth memorizing. Maybe it is, maybe it's not. It's kind of up to you individually, but you want to be able to do that. Now, another one that came up, I don't remember if it came up on the, what made me think of it. Oh, I remember. If we go to our website here, down to the web links and the practice, the antiderivative practice, under this section where it says you can practice integration by parts. Now, I finally did get this one thing to work. Did anybody try this on their computer? If you use Flash, I think that might work, or Java, whatever. So there's about 4 good examples here. But one of them is just plain old arc sine by itself, and it's on the page that says integration by parts. So I want to talk about that. Down here it says some problems like examples 1 through 4, because we're not going to worry about 5 and 6, ones like that, but 1 through 4 would be good. So I finally got my computer to work. If I click here where it says using Java, now I had to go in and change my security settings. I had to download, or I had to update Java. I mean, it was a whole pain to make happen, but I finally did get it to work. So I'm not sure if your Chromebooks work or your home computer, if you can get it to work. Well, it seems there it is. So, and like we talked about, your integration by parts are going to be these kind of things. Here's an algebra with an exponential, right? Want to change a problem, here's an algebra with a log. Change a problem, here's an algebra with a cosine. Here's an algebra with an arctangent, right? Here's an algebra with a log again. Algebra with an arc sine. I mean, that's what your integration by part ones are going to look like. So this isn't a bad place to go to do some practice if you can get it to work on your computer. And then it'll take you through the steps, and so forth. It'll show you. But again, if you can get it to work on your computer, it's not a bad one. But if nothing else, you can see, if I back up here, whoops. So if I just look at them here, these four aren't bad here. You know, there's an algebra with a trig, here's an algebra with an exponential, here's an algebra with a log, here's just a plain old arc sine. I mean, those are probably the types I'm going to give you when it comes to an integration by parts. Okay, so you should be able to recognize it. Well, yeah. So let's talk about that. So let's say you had a problem that was simply arc sine of x, right? What is the antiderivative of arc sine of x, right? And there was one that had 3x. Well, that would just kick out of 1/3, so not a big deal there. But how would you do that? Well, it was on the integration by parts page, right? We don't have a rule for this, but integration by parts would work, because if you look at integration by parts, Liate, the second one in is inverse trig. That's what you pick for your u. So let's do this one here real quick. So we would let the u be arc sine, because we do have a derivative of arc sine, and the dv would be everything else. Well, what's left? Just the dx. Sometimes that happens. So normally with integration by parts, we're looking for two parts. One for the u, one for the dv. Well, it might be that the dv is just the dx. That's the only other part. And we can do that. So let's take a look here. This would be, du would be what? What's the derivative of arc sine? Right? So it's all that. Now what's the v? Right? I mean, if you think about it, the dv is 1 dx, and the antiderivative of 1 is x. So it would be that. So according to the integration, so it's just nice practice here for today for just reviewing integration by parts anyway. But if you take u times v, that would be x arc sine x minus the integral. Now, here's another thing I've noticed with some of you on integration by parts. This integral is supposed to be v du. Now, sometimes we just write down v, write down du, and then get confused as what to do. You got to put those together and sometimes simplify. So in this case, we would take v times du. Now, how would I write that? Nothing really simplifies, but where would I put the x? On top. I think it's best to put that on top. We're used to seeing that. And so we would end up with this right here. Now, we always want to hope to end up with an integral we can do. Can we do that integral? Not just with a basic antiderivative, but could we do that? What would we do? Let u be the inside, right? So this is nice just to pray. You might not have to do a whole thing like this, but just to practice this u substitution is worthwhile here. So u is 1 minus x squared, because we know the du will be negative 2x dx. Sure enough, there's an x dx setting right there, so we're good. So du would be negative 2x dx. We divide the negative 2 over, because it's not setting in there anywhere. So we got our x dx. So this is going to sub out as a negative 1/2 du. The bottom is going to sub out as a square root of u, which is u to the 1/2 on the bottom, so that'd be u to the negative 1/2, right? Everybody see what I did there? So the bottom is square root of u, it's u to the 1/2, but it's on the bottom, so it'd be u to the, it's not an ln, right? ln is only if you have u to the first down here, right? 1 over u, that's an ln. You have u to the 1/2, that's a power. So we're going to raise that up to 1/2, divide by 1/2. That'll cancel those. And so we'll have negative u to the 1/2 plus c. All right, let's put it all together. We got minus and negative. So the whole answer is going to be x arc sine of x. That'll turn into a plus. And then it'll be square root, or u to the 1/2, doesn't matter. And u was 1 minus x squared plus c. So there is the antiderivative of arc sine. Now that's probably not worth memorizing, right? That'd be a hard one to memorize. So just understand, if you're asked to do the antiderivative of arc sine, you say, I don't know the antiderivative of arc sine. It's got to be one of the two ways we've learned. It's not u substitution, because there's nothing to let u equal. So it's got to be integration by parts. So if I ask you to do that one on the gateway test, that's your only option to do it. Okay? And there's another one very similar to that. Let's write this one down. If you think about the types of functions we've had so far that we don't have antiderivative rules for, tangent was one. We showed how to do that. Arc sine, we could have done the same thing with arc tangent, and it would have worked very much the same way. So we could have done those. And then natural log. We don't have a rule for this antiderivative. We don't have an antiderivative for natural log. Okay? Well, let's do integration by parts. So Liate, L, the very first thing in integration by part is let u be the log. So we're going to let u be the ln x. And what's the dv? Just the dx, whatever's left. Remember, dv is whatever's left. Okay, so du is 1 over x dx, and v is x. So integration by parts rule is u times v, so that'd be x ln x minus the integral of v du. So let's think about this. V du, x times 1 over x is x over x, which is 1. What's the antiderivative of 1? That was pretty easy. So it ends up being x ln x minus x plus c. Now maybe you can memorize that, maybe not. But that is the antiderivative of natural log. Okay? So, some of those basic functions we have can be gotten. If we don't know their antiderivative, we can get them by using these techniques. So I thought that'd be worth looking at. All right, any questions on that PD? Oh yeah, Kelsey. Okay, hold that thought, and then we'll get to those. How about in this packet, or that PDF, any of those, if you hopefully finished those, any of those you were kind of wondering about where those answers came from? Is this the one? Yeah. Anybody? Anybody have anything? I was going to comment here on 8 and 9. I was kind of, well, actually 8, 9, and 10. I was just kind of curious. Wanted to make sure we covered everything going on there. So on 8, what was the key to 8? Split it, right? I mean, this is one where you can sit and look at for a while, and you could say, well, maybe should I let u be the bottom, and you can really overthink it. No, this is just a split it apart. This over x would be 5x cubed, and 1 over x is going to be an ln, and so we're just going to raise that up to a 4, divide by 4, and we're going to do an ln, and, you know, and that's it. Oh, it's not a plus c, though, I guess. Then we'll put our 1 and our e in. And then also keep in mind, no calculator, so if you do plug an e in, you're going to have 5/4 e to the 4th, ln e is 1, minus, and then you put a 1 in, you're going to have 5/4 ln 1 is 0, and then you should simplify that, right? I mean, this would be, that you can't simplify, but 1 minus 1 and a 4th, that'd be minus a 4th. So you should simplify that, right, down to something like so. All right, there might be one with some fractions in there that might get a little messy, but all right, number 9. What was number 9? Okay, how'd you do it? Isn't it an integration by parts? And what was tricky about that is it doesn't look like most of the integration by part ones we have. Usually we don't have division in it. But you had to write it as bring that up and then do it this way. And then it's an integration by parts. It's an algebra times a law. And then do your Liate thing. But if I would have changed that just a tiny bit to this, then what would it have been? Now maybe you could have done integration by parts on that. I suppose I didn't even think about doing integration by parts, but here you'd want to let u be what? The top, which is unusual. Yeah, we almost never let u be the top, but here if we let u be ln x, the du is 1 over x dx, which is sitting right there. So that's why we would pick u to be the top, but I didn't even think about making that x to the negative 1 and then ln. What would we, if we did integration by parts, what would we pick for the u? Log, Liate, L would come first, and the dv would be, actually we would want to leave it 1 over x, wouldn't we? Yeah, so then it would, so the du would be 1 over x dx, and the v would be ln. That's weird. Let's look at it. So we get u. I'm trying to think. I should finish this. We'd have du. So this would sum out real nicely. 1 over x dx. This would be u. So we just get u du, right? That's all we get. So that's 1/2 u squared plus c. That'd be 1/2 ln x squared plus c. That'd be the answer. Yeah, so here we have ln x times ln x, so that'd be ln x squared, u times v, minus the integral of v d. Oh, this is one of those repeating ones. Oh, I've never even tried. So what we end up, well, there it is. So we end up with the integral of ln x over x dx is equal to this minus this. It's one of those where we'd add it over, right? We'd add that over, so we'd have 2 of them. Divide by 2, same thing, 1/2 ln squared. Okay, that's an unusual one, where you could do a u substitution to make it work, and you can do an integration by parts and make it work. I didn't even think of that, but I thought, well, why not? If we did that with the algebra, why couldn't we do that one? But again, what I like about you saying u substitution on this one is you're thinking, okay, if I let u be the ln x, I'm looking for the du to be sitting there, and it is. It wasn't when it was a squared, so we had no option. Okay, and then this last one, what was kind of tricky, if you did this one, what was this one? It was actually a what in disguise? It's actually an arctangent in disguise. Whenever you see 1 plus something squared, you're looking for that. Well, what is this squared? This is 2x squared. So you would want to do a u substitution of 2x, and if you went through and did these and looked at the answers, you saw that's what it was. So you let u equal 2x, and that's going to end up giving you your arctangent. Because you can't do an arctangent with a 4x squared there, right? It's got to be 1 plus a u squared. And so you let u be the inside. Well, that would just come out, that's where that 1/2 would go. So what I would do with this is this 3 on top can actually come out. Yeah. And so this would be 1 plus u squared, and then your dx would be a 1/2. So that would come out here, du. So it ends up being 3/2 arctangent. Yeah, 3/2 arctangent and then 2x. Oh, I got you. Yes, and we probably haven't done enough of that. So in other words, you're saying this. Sometimes I've skipped those just because. Yeah, that's a good one to talk about. So in other words, when you do your u as the bottom, and you've often heard me say, okay, when I do my du, I'm going to get 6x dx, but I don't really care about the 6, right? We'll deal with that. I say that a lot. We'll deal with that. It's the x dx I care about, and the same thing here. The x dx is what I care about, the 5. When I say we'll deal with it, well, what I mean is we'll pull it out. So let's look at that. So we get 6x dx. So yeah, this I would move over here. Yeah. And then on this integral, I would take this 5 and I would just pull it out front. So I've got my x dx, which would be a 1/6. Let's do it over here. So the 1/6 would come out in front with the 5, and then what's left? That. So it's 1 over u, so it's an ln. So then it becomes 5/6, yeah. And I don't want to downplay that because I might put those on there, right? I mean, I might have those on there. So yeah, any 5 that's multiplied times the top can come out. Yeah. All right. So that's all I really had on these. So then, Kels, did you have another book one?
Yeah, I tried to do 61
What is number 61? So cosine x, sine x to the 4th. Okay. All right. So let's catch everybody else up to speed with what you guys are saying. Jacob, you seem like you're not sure what they're on. Well, you didn't try this one, right? 61. Okay, you did some of the ones around it, but not 61. Okay. All right. Well, first thing I think that's important is that you let this, you put, when you do the fourth, like sign to the fourth, that you put it on the inside, right? You write it this way because then it becomes obvious. So let's catch everybody up to what you said. So I'm guessing you did this, right? You let U be the inside, the sign. Yeah, and the nice thing about that is you get cosine x dx, which is all setting right there. So in your substitution, that's going to come out and just be the du. This will be 1 over u to the fourth, so that's u to the negative fourth. Raise that up to a negative 3, divide by negative 3. So you get this. So you get negative 1/3 sine. No, I would just leave that. So what did they tell me what they changed? Cosecant to the third. Okay. So what they're saying is negative power, if you flip that, that's cosecant, and then to the third. Yeah, no, I would leave it. I always think they're better left with sines and cosines. Maybe they're thinking they'd rather have a positive power. But yeah, I would do. I'm not sure what the calculator would do for you if you checked it there, and that's what I would suggest. I think a big part of your review for Monday will be the book problems. I think that's a good place to go. So using your calculator to check them is good. Of course, the odd ones might be in the back, but just like that one, they write it sometimes in a strange way. Calculator didn't. Oh yeah, on that one it didn't work. Yeah, no, I still have confidence. I'm still not sure why that didn't work on that one. Okay. Any others? Any others from the book or the LH or the website or whatever? Okay, what's that one? X squared plus 1. I think we did this one.
I don't think so.
You sure?
I don't know. I started it and have a big X through it. So I should do it.
I could have. Maybe it's the other class. All right.
I don't know what you're talking about.
Well, obviously you don't remember it, so let's do it again. It's fine. That's fine. Well, what are your options?
Let's do the bottom. Yeah.
Let u be the bottom. And then let's think ahead here now. So that would give you 2x dx. The 2 I don't really care about, right? We'll deal with it. But x, there'll be an x dx. Do I have an x dx there?
Yeah.
Not really. I've got an x plus 4 dx, and we can't just like take away a 4, right? You can't do that out of there. That x plus 4 is combined. It's like x plus 4 times dx. So we don't have an x dx. So that's the problem there. So, and it's not a integration by parts.
We split it. Yeah.
Split it. We can't, now remember, we can't split the bottom. But we can make this into this plus this. Does still not look familiar?
Guess what? We did it.
Oh, maybe we did. What? You have it written down? Well, because I thought I told the other class, I did this in the other class, and I told them, well, yeah, we didn't do this one here. I did it in the other class. I thought it. Well, anyway, so now with this one, we can do what we were thinking, which was let u be this. And so the du is 2x dx. So we can divide the 2 over there. We get 1/2 du equals x dx. So now that's going to sub that out as a 1/2 du. The bottom then is the u, so we got 1 over u, so that's our log one. We've seen that a lot now. 1/2 ln u. X squared plus 1 will not be negative, so I don't need the bars. Right? X squared plus 1 will never be negative. You can have the bars, right? Leave the bars there, it's fine. What about this guy here? That's an arctangent, right? It's just a 4 out in front, and it's an arctangent. So it's 4 arctangent of x, and then plus c. So that is a strategy where we can, as long as you don't split the bottom, you can split the top. So if you ever see a plus up there, now, we've seen that a couple different situations when we have a plus up there. Let me just throw a couple at you here real quick. This one, if you had say a 2, I think we did one of these, although my confidence in what we've done and not done is shaking right now. But anyway, didn't we talk about something like this? And here, we don't care about splitting this up because if we let u be the inside, we get 2x plus 3, right? We get 2x plus 3 dx, and so that'll sub out nicely, and so we don't have to worry about that. Okay? Now, let's take that one we just did and let's flip it around. I have a review sheet of some problems we're going to do in class here today. Let you work on in class, and this is one of them. But what the heck? Let's do it now. It's like this. So when you see it, I'm hoping in 15 minutes, when you see it, you'll recognize it, right? And be able to do it. Okay, so look at this. All I've done is flipped around the one we had a minute ago. The integration by parts ones I'm going to give you are going to be algebra and a log, algebra and exponential, whatever. It's usually not just algebra with algebra. Because there's just no good way to do it. I could rearrange and move this up and try u and dv, but it would just be a mess and it would never get you anywhere.
Could you still split it? Does that help at all?
But I don't think it'll help. Yeah, because if you do split, you get 1 over x plus 4. Well, actually, 1 over x plus 4 is not bad. Isn't that just an ln? 1 over x plus 4 would just be an ln. So the x squared over x plus 4 is a problem. But actually, so you could split it, but it really is to no advantage to split it. I'll show you when we actually get to the answer here why it isn't an advantage to split it. Well, what are your options? I mean, we don't have very many options. I mean, really, it's not integration by parts. It's not a basic one. It really is u substitution. It's about all we got. And so what's about your only choice? The bottom. I mean, that is about the only choice. You could say the top, the derivative is 2x dx, but there's definitely not an x dx setting here, right? I mean, there just isn't. It's on the stuff that's setting there is the bottom. And so, yeah, we got to pretty much let u be the bottom. And then just see where we go. This might be one of those where we're going down a blind alley, right? I mean, you might get one of these and you're like, I don't recognize this. But what are my options? You start going through your options, you don't have a lot, right? And so let u be the bottom is about what you got. Now, hopefully, once you get down this blind alley, all of a sudden you'll see something familiar and you'll be able to, you're like, oh, yeah, okay, do that. So let's see what happens. So we get du is just dx. So we start subbing out. So that'll be du. That'll be u. Okay? Remember that where we said, now what do we have? We have an extra x is what we have, right? It's actually an x squared, but whatever. So the x is going to be that. So this will be u minus 4 squared plus 1. Now is that helpful? Because, well, before we split it, FOIL. We actually will want to FOIL that out. And this is why it wasn't an advantage to split it, because we'll just add the 1 on. So we're going to get, what we're going to get here is u squared minus 8u plus 16 plus 1 is plus 17 all over u. And we won't finish it. I'm going to let you, we got one later we're going to do it. You can do that one then. But now we just split it up. Now we have u minus 8 plus 17 over u. Well, there's the ln. The one at the end will be an ln. And then those other, then they're just power rules. So what happened here is we let u be the bottom. Even though that didn't give us our du, all that was left was some extra x's. And anytime you let u equal something with x in it, you can solve for x and take care of any extra x's. So that's what happens with that one. But that would not have been an option back here. You know, letting u be the top wouldn't really have helped you here because you'd have put that in for extra x's, but all your mess would have been on the bottom. And that's not what you want. You want a mess of stuff on top's okay with a single bottom because then you can split it up. Okay? All right, so there we go. with that. Well, let's go ahead and start on this other set of review ones that I have. And today might be best just to do them on your own. Try to on your own. I don't care if you talk about them with each other a little bit. But, gateway test is Monday, so we're getting to the point we should be able to do some of these on our own. So here, I got about 8 of them here. Okay, I got about 8 of them today. So here's the first 3. I'm not sure why I made those with A's. I think on the gateway test all be X's, but it doesn't matter what the letter is. But okay, so there's 3 problems right there. So I'll give you a little time, do those, and I'll throw the answers up. Then we'll do a few more, put the answers up. And then if you got some time left at the end, you can practice some more.